Okay, so today's video is over lesson 4.2a. It's the first part of the lesson, and the reason why we split it up is because the first part is numbers only, and 4.2b would be variables included. So it's very important that when you learn this material, you do it without as much calculator as possible. So when you do use your calculator, typically use your calculator to multiply, divide, add, but not to simplify, okay? We've got 3 goals for this lesson. The first goal is to simplify with rational exponents. And honestly, I feel like that's the one that's the most difficult because it looks kind of weird. You're using a lot of different rules. And all of these rules are coming from Algebra 1. And it's really hard to remember them without a lot of practice. This one is actually very basic. Okay, you're just combining, you're either multiplying or you're dividing. So it's pretty easy compared to the first one anyway. And then you're going to write radicals in simplest form. This one, you absolutely cannot depend on your calculator to simplify, especially like cube roots. Square roots, yes, but cube roots, no. So our first goal is to simplify expressions with rational exponents. And if you look at all of these rules, it might be overwhelming because there's a lot of fractions. The only difference between this and what you did in Algebra 1 is just fraction exponents. So what I want to do is I want to just kind of go over here to the side. Y'all are going to have your dry erase boards. And I just want to ask you some questions about basic expressions. Okay, so the first one's going to be 2 to the power of 5 times 2 to the power of 7. We want to do this without our calculator, okay? There's a way that we can simplify that. Now, if you look at your notes, I'm not going to constantly go back and forth, but if you look at your notes, there is a rule that says if you have the same base, in this case it's 2, and you're multiplying the number 2, and they have exponents, what do you do with your exponents? We add them, okay? This is actually your first rule. It's called the product of powers. And you're going to do the same thing today. Instead of it being whole numbers, it might be 1/5 or it might be 3/7, okay? But you're still going to do the same thing. The reason why I'm kind of taking this to the side is that a lot of people want to put 35. What are they doing here instead of adding? They're multiplying, okay? That's a different rule. And some people want to put 4 here. Why are they wanting to put 4? They're doing 2 times 2. Okay, so when you actually observe the rule, you keep your base the same, and then you add your exponents, so it'll be 2 to the power of 12, right? And you should be able to do it without a calculator. So the next one I want to talk about is a little bit further down. It's called quotient of powers, and that's as if you had like 2 to the power of 7 over 2 to the power of 5. Well, sometimes people say, well, 2 divided by 2 is 1. You don't do that. You have to keep the same base. It'll be 2, but then it'll be 7 minus 5. So 7 minus 5 is 2. So it'll be 2 squared. The only difference between that and what we're doing today is that these are probably going to be fractions. So it might be 1/7 and 1/5. So you can just use your calculator to do like 1/7 minus 1/5, okay? Negative is going to show up, but I've got an example for that one. Just remember that if you have something in parentheses, that everything is going to be affected. So that would wind up being 2 squared m squared. And if you already had like 2m to the third, so if you have existing exponents, now I guess you always have exponents. If you don't see them, put a 1 there. So this would be 2 squared m to the 6th power. So that is when you multiply your exponents, when you have a power to a power situation. Okay, so example number 1. Here's what you want to do. You need to look for similarities. Like, look to see if your base is the same. Okay, so my base is the same. Awesome. What are you doing to the base? Are we multiplying the bases? Are we dividing the bases? In this case, we're multiplying, right? So what I can do is I can use that power, the product of powers, and I can write it as a single base. I can say base 2. And then we're going to do 3/4 plus 1/2. So you're going to add the exponents together. So if you need to use your calculator to do this, you can. So if you type in 3 over 4 plus 1/2, you wind up with 5 over 4. Now, when I was learning this, the biggest question I had was, how do I know when I'm done? Like, I combined the bases. I have one base. That's good. But how do I know I stop here? If you start with fraction exponents, you don't have to write it in radical form. So you can leave it 5 over 4. I do have one more question for you, though. Can you take the 4th root of the number 2? So if I did rewrite it, if I said 4th root of 2, can I simplify the 4th root of 2? No. So I'm done. All right. If you can simplify it, great. Go ahead and simplify it. But if you can't take the 4th root, then don't. That's your final answer. Okay. So let's talk about number 2. What do you notice? We notice that we have the same base. I have base 3. I have base 3. Now, it kind of annoys me at the very top. I don't have an exponent. I do. So I'm going to put the little 1 there. I'm visual. I like to see the exponent, so I put 1 there. Now, you got to think, what is the rule when you're dividing the same base? Okay, that rule states that you subtract your exponents. So you're going to have to go in the exact order that it appears. So you're going to write 3, because you don't change your base. Okay, don't do 3 divided by 3 is 1. That's not what it's saying. So we're going to do 1 minus 1/4. Now that's when you can use your calculator. Like 1 minus 1/4 is 3 over 4. How do you know if you're done? Can you take the 4th root of 3? You can't. Okay, so you're done. There's nothing, no other rules that I can apply. I can't simplify. I'm done. Okay, so question number 3. It doesn't have the same base. 20 and 5 are not the same. So I'm going to have to take a different approach. So what you could do is you could do a power to a power. So y'all see that 3 hanging out right here? I'm going to multiply all of the exponents by 3. Okay? So that's going to be 20 to the power of, and you can use your calculator, 1/2 times 3. That's just 3 over 2. And then I'm going to do the denominator, so it'll be 5, but I have to do 1/2 times 3, and it still gives me 3 over 2. So that was a power to a power. So now my question for you, what do you notice? Your bases aren't the same, but what is the same? The exponents are the same. If your exponents are the same, you can actually work backwards. So look at power of a quotient on your notes. It's right here. It's the last one. Okay, do you see this right here? See how they have different bases? You have A and B, right? But the exponent is the same. What you can do is you can go backwards. You can write A and B in parentheses and then just write one exponent for both bases. So I'm going to do the same thing here. I'm going to write 20 over 5 in parentheses, and then I'm just going to have one exponent for that whole fraction. So you make those rules work for you. So you can go backwards too. So my question is, can you do 20 over 5? Yes, you can. What is 20 over 5? That's 4. Next question. Can I take the second root or square root? Can I take the square root of 4? Yes. So if your answer is yes, then you need to take that. So what is the square root of 4? It's 2. What do I do with a 3? You got to raise it to the power of 3. So the denominator is the square root. So the square root of 4 is 2. And 2 to the third power is 8. So if you can take that root, go ahead and take it. Okay, question 4. Y'all see that 5 and 7 are different. So I can't use any rules with 5 and 7. And even the exponents on the 5 and 7 are also different. So really the only thing that I can do is get rid of this 3. How do I get rid of that 3? I'm going to use power to a power. So I'm going to say 3 times 1/3, and I'm going to say 3 times 1/4. So you can use your calculator. 3 times 1/3 is just 1. And then 1/4 times 3 is 3/4. Now, like I said before, 5 and 7 are different. I can't combine them because they're different. The exponents are different. Can I take the 4th root of 7? I cannot. Looks like I'm out of options, so that is my final answer. So on example number 5, I'm going to show you a trick that's not in your book. It's kind of a neat little trick. So y'all see this little negative right here? If you have a negative exponent, I'm going to go off to the side here for a second. So the other day we talked about if you have a to the power of -1, to change your sign of your exponent, you just write it in the denominator. So if you wanted to go the other direction, let's say it's already in the denominator, you would move it up to the numerator and it would be positive. That's the only thing that would change your sign of your exponent, okay? I'm going to do both at the same time. See how the 2 is in the numerator and 3 is in the denominator? We're just going to write the reciprocal. So I'm going to flip this one to the top, flip this one down to the denominator. And when I flip both, when I flip everything in that fraction, that is now positive 1/3. So it's kind of a neat trick to get rid of a negative exponent on a fraction. The 3 and the 2 are different. I think the easiest thing for us to do is a power to a power. So I'm going to multiply my exponents times 1/3. So 3 times 1/3 is 1. And then same thing here, 3 times 1/3 is 1. So it's basically just 3/2. It's really nothing else for me to do here. Okay, last one. I'm gonna give you a second to look at this. There's a technique that I've already used today that you can use to make this look so much easier, okay? So just kind of look and see what you have that's different, what's the same. Pause the video and see if you can figure it out. Okay, so none of these bases are the same, but I did notice that all the exponents are the same. So what I can do is I can write all of this stuff together. So all of these bases are going to be written together in parentheses, and I'm going to put 2/3 on the outside. Now, why did I do that? Why is that necessary? Can I take the cube root of 2? No. Can I take the cube root of 4? No. So unless I actually write it this way, I'm stuck. On the other hand, can I do 2 times 16? Yes. 2 times 16 is 32. What's 32 divided by 4? 8. So you can just simply do 2 times 16 divided by 4 and you get 8. Now before I box this in as my final answer, you have to ask yourself, can you take the cube root of 8? You can, okay? That's why it's so important for you to know the perfect squares, to know the perfect cubes. So the cube root of 8 is 2. And then you have to take care of your power. So 2 squared is 4. Final answer. Okay, so our second goal for the day is for us to be able to simplify radical expressions when we are multiplying and dividing. You don't have a ton of rules for this. It's literally like one rule. The rule is that your index has to be the same. So if you have a square root times another square root, you have the ability to combine it into one square root. If you have a cube root and you're dividing or multiplying, it doesn't matter. As long as your root is the same, you can either combine it or you can separate it, whatever it is that you need to do. So if you look right here in this example, They have the cube root of 4, which you can't do. You can't do the cube root of 4. And you can't find the cube root of 2. So what they did is they combined it. They said 4 times 2 is 8. Can you take the cube root of 8? Yes. So sometimes it's better for you to separate. Sometimes it's better for you to combine. So let's do this over here. So right now, the cube root of 4, I can't do that. The cube root of 128, it's not a perfect cube. But what I can do is I can combine them. So use your calculator and do 4 times 128, and we get 512. Now, 512 is one of those numbers. You may not know it off the top of your head, but if you look a little bit further down, do you see it? 512. What's the cube root of 512? It is 8. The cube root of 512 is 8. 8 times 8 times 8. Okay, so same thing here. Now, I don't have a, fifth root. I don't have a list of fifth roots. So you're going to have to be clever. I can't take the fifth root of 6. I definitely know that. So what I'm going to do is I'm going to combine them. I'm going to divide 192 by 6, see what I get. And I get 32. Well, I just happen to know that 2 to the power of 5 is 32. So can I take the fifth root of 32? Yep, I get 2. Okay, so I just need you to take a second, look at your notes. This is not going to be provided to you. As juniors in high school, it is generally accepted that you guys know your multiplication tables and you should be very familiar with your perfect squares. Okay, you should know those. I keep telling you that you need to know these first 5 right here. It's necessary. If you don't take some time, just like memorizing your multiplication tables, this content in this chapter is going to be difficult for you. I need you to spend some time looking at that, okay? All you got to do, even if you forget it, you can just do it real quick on your calculator. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So you can run yourself a little list, even if you don't have it with you, okay? With that being said, this is why you need to know, okay? Now, if you type in the square root of 20 right now on your calculator, go ahead and do it. Type in the square root of 20. I'm going to pause the video, give you a chance to do that. So when you type it in your calculator, you immediately get 2 square root of 5. Cool. Thing is that you're going to have to be able to do this without a calculator. There is going to be part of your test, end of course test, and in-class test where you have to do some of this stuff without a calculator. So how do you do it without a calculator? What you need to do is you need to look at the number 20, okay? And you need to think, what are perfect squares? So my perfect squares are 1, 4, 9, 16, so on and so forth, okay? Now 1 is not going to help you, all right? But format, you need to ask yourself, what is the biggest perfect square that will divide into 20 with no remainder? So the biggest one that will divide into 20 is 4, okay? 4 will divide into 20, right? So remember, you can go backwards. So what I'm going to do is I'm going to change this from 20. I'm going to say 4 times 5 is 20. So what you're doing is you're taking this number that you can't do the square root of, and you're splitting it into parts that you can take the square root of. So I can take the square root of 4. So I will do that. I'm going to split it up. I'm going to say square root of 4, square root of 5. I'm going to go ahead and take that and say that that's 2. So my final answer is going to be 2 square root of 5. This is the same technique that you use for a cubic. Now I want you to type in the cube root of 500 on your calculator and tell me what you get. And I'll pause the video again. So when you try to do this on your calculator, it's going to give you an approximation. This is not simplest form. Simplest form is when it's not rounded. So your calculator is a no-go. It's not going to happen on this one. So what you need to do is you need to look at your perfect cubes. So my perfect cubes are 1, 8, 27, 64, so on and so forth. 1 is not going to help you, so I'm going to start with 8. Does 8 go into 500? Had somebody ask me earlier today, how do I use my calculator to check that? 500 divided by 8 is 62.5. Is that going to work? No. Okay. So 500 divided by the next number would be what, 27? That's a no-go because it says 18.5. Okay, 500 divided by 64. And you just keep going until you find one. 500 divided by 125 is 4. Perfect. So here's what you're going to do. You can't do anything about 500, but you can do something about 125 and 4. That's what you have to do. This has to be a perfect cube for you to simplify it. And yes, your calculator can help you. It just won't do the problem for you. So the cube root of 125 is 5. So I'm going to take that. I'm going to write 5. Can I take the cube root of 4? No. So I'm just going to leave it cube root of 4. And that's exactly what your Delta Math wants you to put in. So these are like little clues, little mysteries, and you have to use your perfect cube to figure out which one goes into it. So take a few seconds and see what will divide into 128. Now, it has to be the biggest cube, though. It can't be the first one that you find. So I'm going to pause it again, and you figure out the biggest perfect cube that will divide into it. Yeah, so if you actually divide it by 8, that's not big enough. 8 times, let me see, 128 divided by 8 is 16. And 16 is also divisible by 8. So you have to use 64. You've got to find the biggest perfect cube. So I'm going to use 64 times 2. That's the risk you have. So 8 can be tricky. If 8 works, try 64, see if that one works. So the cube root of 64 is 4. And I cannot do the cube root of 2, so it has to stay. Okay, and then one more time, just use your calculator. 1,125 is a really big number. See which one will divide into that number. And I will pause it. Okay, so on your calculator, if you divide this by 125, you get 9. So that is what I'm looking for. So 125 times 9 is what we started with. I can take the cube root of 125, and that would be 5. I cannot take the cube root of 9, so I have to leave it cube root of 9. Did I skip a little bit of step there? Yes. Now, once you get used to these, you can do it like that. Okay? And we are done.